Alright, so this is video 1 for first period. There's sort of the outline of what'll be in each video. And again, in each class I'll work those preset 5 questions so that I get them all in video, and then after that I'll take whatever questions you have. So let's look at number 1. And even though I'm recording, stop me if I do something quick or wrong, ask me questions if you need something. Solve each equation, show all steps algebraically. It says you can use the calculator on the review, but not on the test. So, it's fine if you're checking or working, but make sure you can do them without the calculator. Okay, I've already got the absolute value thing by itself, so let's split them up. 8 plus x equals 2x minus 3. And 8 plus x equals, change both signs, negative 2x plus 3. So I'm going to move the x over and add the 3 over, so x equals 11. And on this side, I'll add 2x over, subtract the 8, that gets me negative 5. So x is negative 5/3. I should check all the problems because I'm a conscientious algebra student who wants to make sure I got them right. I definitely have to check this one. Do you know why I need to check this one? What about this problem?
Because there's a variable on each side.
There's a variable, I'd phrase it this way, there's a variable not in the absolute value bars. So if there's a variable outside the absolute value bars, you definitely need to check because maybe something goes wrong here. So let's check 11. 8 plus 11, that would be 19. On the other side, 22 minus 3 is also 19. So we're good with 11. Negative 5/3. That's kind of annoying to check with the negatives and the fractions. But the thing that usually messes up is the negatives and the positives. So look at this one. You don't have to check too hard. The left-hand side is definitely going to be positive. And the right-hand side, I don't know what negative 10/3 minus 3 is, but I do know that negative 10/3 minus 3 is negative. So that one won't work. Got to check, but even then the check is sometimes usually just a matter of positives and negatives. So that was a good one right out of the gate. How to set up an absolute value equation, split it up into 2 pieces, and then don't forget to check. Number 5. Even before I start number 5, am I going to need to check number 5? Yep, because of that x. Because of this x right there. So already I'm thinking, better be careful, this one might not work for us. 4x minus 1 equals 5x plus 37. 4x minus 1 equals negative 5x minus 37. Make sure you change all the signs. So subtract 4x over, subtract 37. It's going to be fun to check. 4 times 38. We'll worry about that one in a minute. On this side, if I add 5x to both sides, I get 9x. Add 1 to both sides, I get negative 36. Well, at least I got one nice number to mess with. Negative 38. Absolute value. 4 times negative 38 minus 1 equals 5 times negative 38 plus 37. Oh, this is kind of similar to number 1. I don't know what 4 times 38 is without... Yeah, but what's this side going to be? Positive. And I don't know what 5 times negative 38 is, but it's definitely going to be negative, right? Even when I add 37. 5 negative 38s and a 137 is going to be negative. So that guy's out. Negative 4. 4 times negative 4 minus 1. 5 times negative 4 plus 37. This one baits people into thinking it doesn't work. 4 times negative 4 is negative 16, minus 1 is negative 17. But what's the absolute value of negative 17? 17. People just ignore the absolute values somehow. And then negative 20 plus 37, yep, that's 70. It's also a good illustration of, on checking, show as much work as you need to check. So this isn't like some formal proof where you got to get it all the way down to 17 equals 17. And even on this side, as soon as you see that positive doesn't equal negative, then you're done. Number 9, inequalities. Okay, so some overlap in process, but also some different steps here. And usually with inequalities, we want to graph and interval notation. So make sure you read the directions. I mean, that's what they're going to be. Graph it and show it in interval notation. That is the question. What is 90 divided by 5? Did we figure out what that is yet? 18. Yeah, 100 divided by 5 is 20. And so 2 5s less than that would be 18. This is one where showing your steps is probably helpful. If people start skipping steps, then they forget and leave off the and or thing. Which type of problem is this? Yep, it's a great or problem. So I'm expecting the outer edges, the greater number of solutions for this one, especially since there's no negatives to mess this thing up. 4a plus 6 is greater than 18, or 4a plus 6 is less than negative 18. Right, I wrote it like 5 times the day we did notes for this. Change both signs. So 4a is greater than 12. A is greater than 3. 4a is less than negative 24. A is less than negative 6. Do I need to flip that inequality because it's a negative?
No.
When do I flip the inequality? When you multiply or divide by negatives. Okay, just because there's a negative over there, that's fine. It's only when you're multiplying or dividing by negative that things switch around. Okay, or. So like I don't need the overlap, I just need anything that's shaded. Greater than 3, less than negative 6. And again, your number line, it needs to have the 2 values that we're concerned with on there, and then any other values you want, but you don't have to put anything else on there. So negative infinity to negative 6, union with 3 to infinity, parentheses because we don't want to include the 3 or the negative 6. Next, number 13. Ugh, 13. Fractions everywhere. What do you want to do first? Multiply by 6? Okay, I'm okay with multiply by 6 because I see 2 options here. If I only look at those 2 denominators, I think multiply by 18. That way it would cancel both of them. But seeing that there's a 2/3 in there, multiplying by 6 would make this one 2/3. So either way. But several people said 6, so we'll do 6. It certainly fixes the left-hand side. So absolute value v minus 2/3 is greater than 2/3. If you really don't like fractions, you can multiply both sides by 3, because you can multiply a positive into the absolute value and be okay. Would you like to do that? You really don't like fractions? I'm okay with that. I mean, it's an easy fix to clear the fractions. And you can do this with positive numbers. Like, don't do this with negative numbers, because absolute values and negatives, that doesn't work real well together. But with the positive 3v minus 2 is greater than 2. Again, that's kind of an optional step, because dealing with 2/3 on both sides is not going to be hard. But Ryan didn't want to mess with fractions, so that's okay. Grade 4, 3v minus 2 is less than negative 2. So I'm expecting another, solution that's heading off to positive and negative infinity. V is greater than 4/3, or add 2 to both sides to get 0. I don't know what it is. Zeros mess people up. They get there and they'll either stop there or they're not sure what to do next. But just forget the 0. What would you do to get v by itself? Divide by 3. And what's 0 divided by 3? 0. So greater than 4/3 or less than 0. Yeah, that'll get me the arrow pointed the opposite direction. Open circle. Less than 0. Greater than 4/3. Try to make your infinities look like infinity and not 8. I get it, it's hard, you haven't done it a bunch, but if you do this, that looks like negative 8 to 0, and then 4/3 to 8, but that's not the solution. So it would be like you're depending upon my kindness at that point if you write that as an answer. And maybe it's close enough, and maybe there's enough work that I can see what you mean, and maybe I'm feeling generous. But maybe I just look at that and I'm like, no, that looks like negative 8, so that's not the right answer. So be careful writing those infinities. Lastly, number 17. Ooh, a whole bunch of negatives. Can I stop right now and say absolute value is never less than negative, so this is no solution?
Because you have the other factor.
Yeah, not yet. Like, it's true that absolute value is never less than negative, but there's more stuff going on here. I can't make that judgment until I have the absolute value thing by itself. Then I can figure out if this is going to work or not. 18 looks kind of similar. Like, there's a negative over there, but does it fix it? It's too soon to say. Same thing with 19. There's a negative over there, but too soon to say. So let's work on solving it first, and then if it turns into one of the weird cases, we'll catch it in a minute. So let's add 6 to both sides. So that would give us negative 32. Then we'll divide both sides by negative 8. So absolute value, negative 4v plus 8, is greater than or equal to 4. So many negatives. We're thinking a lot of things at once here. So we flip the inequality, and the negative over negative became positive, so we're not worried about the no solutions issue here. Negative 4v plus 8 greater than or equal to 4. And I guess poor planning on my part, this is yet another OR problem. We can hit an AND problem. Negative 4v plus 8 less than or equal to negative 4. So negative 4v greater than or equal to negative 4. Divide by negative 4. Switch that around. V is less than 1. And all these negatives. So switching things around. Negative 4v less than or equal to negative 12. Divide by negative 4, so switch the inequality again. V is less than 1 or greater than 3. Yeah, that's what we expected to happen. 1 1 and 3, close circles, and we get to practice writing infinity again. So there's our answer. Okay, that concludes the video part for part 1. If you're looking for any of the other questions, there's where they will be if you need something else.